Let's start with NVM. This is the most important module in the memory stack of AutoSAR. It stands for Non-Volatile Memory Manager. So basically, it is a manager of memory. And what kind of memory? Usually the non-volatile memory. Okay. So what is the need of NVM? See, this is the part of the service layer. When I showed you the different layers, there was the service layer. And in the service layer, the NVM provides services for data storage and modification. So, in order to store data or to modify it, all these operations can be done using the NVM module in AutoSAR. It is hardware dependent is another interesting property. So, it doesn't depend on what is the underlying architecture. We can use this module without knowing that. If somebody is going to modify some memory, they can directly use NVM without knowing what is the underlying architecture because it's memory or hardware independent. Now the NVM is serving as a mediator between software component and NV memory. Okay. But that doesn't mean that we can just use this directly, or what we can say, it is like only this module is required. There are the other modules that are also part, like the driver layer modules, the abstraction interface modules, etc. But the basis is that the NVM will effectively communicate with these different modules and application, and finally act as a mediator between these different modules. Now, the roles include memory initialization, error detection, and error recovery. So, if we have to initialize some of the NV blocks with some value, that can be done using NVM. We can try to detect any corrupt data is present in the NV storage, that is called error detection. And finally, if some error occurs, for example, in case of the redundant block, we have a backup copy, right? So in that kind of cases, we can actually attempt for an error recovery. So these are the roles of the NVM module. Now some features that are available to NVM module, we will discuss those. So first one is startup shutdown handling. So basically, whenever the ECU is starting, that's called the startup phase, and when the ECU is going to sleep, that's called shutdown phase. So in both these phases, it is important to handle memory properly. So while starting up, we might need to read some values and then act upon it. And also during shutdown, we need, for example, to store some important information. So that's what we mean by startup shutdown handling. So this is a feature of NVM. Next is synchronization. So you in synchronization, what we do is the different application, for example, software components are present and they will be accessing the common NV memory or the common memory. And then there can be the different NVM modules which are actually working parallel with the application. So, for example, one side NVM is acting on the memory, and the other side the application is updating the memory. So, it's important that there should be some synchronization. So, synchronization is a feature that is provided by NVM. Next is called as configuring RAM block states. So, when at the runtime we have the RAM block, right? So, in the RAM block, if you remember, there is the admin block and etc. So if there are RAM block, then admin block, all these blocks are there, right? So the states of the RAM block can be configured using NVM. So this is called as configuring RAM block states. Then write protection feature. Okay, so it is possible to protect the data that is stored somewhere. The modification of this data can be prevented, and this is called as write protection. Another interesting feature we have already discussed is the CRC check functionality. So this CRC check functionality helps us to perform some CRC check to ensure the data is correct. And finally, there is the configuration or compatibility check that is also available. So if we need to check the configuration is right, or if the different memory like data sets are compatible to our current software version, we have something called as compatibility check, which is provided by NVM. Now let's discuss the memory abstraction interface, which is also called as MEMF. Okay, so this is the module that is coming just below the NVM in the AutoSAR stack. It is part of the hardware abstraction layer, which we already discussed. So the role of MEMF is that it provides abstraction. So basically, there is NVM, then MEMF, then the underlying architecture. Now, MEMF will provide a virtual segmentation or a virtual address space, which is used by NVM to communicate with the underlying fee or the what we can say the driver modules for Flash, EEPROM, etc. So this is how NVM is able to act hardware independent. The reason is MEMF is abstracting the address range to NVM, and thus the MEMF acts as a mediator between NVM and the lower layers, and it provides a uniform linear address space to NVM. Now, in MEMF, we give a device ID, okay, which is called given by the parameter device index. So we use this ID to actually differentiate between different kinds of hardware. For example, EEPROM is one device which can have an ID of 0, for example. Then there is Flash, so we can give it an ID of 1, for example. So that's what we call by device index. Okay. And this device index, as I told you, helps to identify the target memory. And then we can have another configurable parameter called as MEMF number of devices. So this gives us an idea of the number of devices that are handled by MEMF. Now MEMF provides two APIs, MEMF read or MEMF write. These APIs are provided to NVM for reading and writing access. So it is using these API, the NVM module actually tries to read or write into the underlying architecture, for example, Flash. So if the NVM needs to write, then NVM has to call this MEMF write API that will trigger the writing to the hardware. Same in the case of MEMF read. So let's summarize. Today we discussed about NVM, which is the non-volatile memory manager. So the NVM provides services to communicate with NV storage or non-volatile storage for different AutoSAR modules, be it application, be it the other modules such as DCM, all of them, DEM. So all of this interact, and this is made possible using NVM. Okay. Then there is MEMF, which provides memory abstraction for the underlying devices to NVM. So Flash, EEPROM, every kind of addressing is provided uniformly to the NVM module.